Hi everyone, my name is Agustin Paisano. I am industrial engineering student. So in this case, I'm going to explain the report of Nomograms. My team is confirmed by Jorge Refugio, Ángel Maya, José Guillermo Mijangos, Benjamin Clackwell, Arturo Jimenez, and me, Agustin Paisano. We are student of the Universidad Politécnica de Puebla. Our teacher is Mariana Tepox Cruz, and I hope you like this video. So let's get started. Well, we have to perform the calculation. We have the following data. We design a pneumatic air distribution system. What does it mean? We put an diagram that is it. There's all our design. We go to the last share. So we have our measures, that is length, rate, pressure, and pressure drop. So this one is a nomogram, and it works to know the rate of if you have a good pneumatic air distribution system. So the first step that we have is to locate all the lines. We have 6 or 7. We have length, rate, pressure drop, and you can say is the same the information that we have. The first line is for length. If you can see, we have a scale, so we need to focus our length in the scale. We start to find out the 100 in the scale. We found it, so we're going to put a dot. Then, and the second one is a rate or caudal, or you can say. Then you put 500 millimeters by 3. All the rate is in millimeters. So it's the same. You can focus in the scale your number that you have your measure, and then we are going to draw a line, length, flow, and x1. And the x1 is important. I'm going to say then. Let me explain this, please. So this has to be straight by touching the three first point. It is more important. So the second one is nominal diameter, yeah, and the actual number 2, and we have the loss of pressure or pressure drop. That is the same. It calls pressure drop because it changed for all the pressure that we have in a time, so we put length, it's okay, rate, we okay. We are going to work with pressure. If you can say, we have the 1, 2, 3, 4, 5. The 5 line is put the pressure. We have 5 bars, so we're going to put a dot or point, or you can put anything you want. Then we are going to put the pressure drop or the pressure loss, the loss of pressure. That it means dot 7 bar. So in the scale, it's the same. You're going to find out this number and put on it. So at the same time, like we did in the same line, we are going to draw the same line, but this is going to be the line between between the pressure drop, the pressure, and the actual 2. There is different. There is another line. So if you can say, we put a line, and the line is a red line. What is a red line in this nomogram? So this is important because this the key to the another nomogram, to the component. So if you can see the union between the line of the actual one and the actual two, there's a coincident point. So we are going to put a dot between the actual and the union, the number, the, if you can see, well, we are going to put a number one and number two lines to don't confuse yourself. So the line number one is correspondingly by length. So in number two, the line number two is by pressure. Yeah, that one. Well, the number line, we have a unit with the actual number one. So we are going to put a point, and then in the actual number two, we have a union, the line, the pressure and actual two. So that is important, the actual, because we are going to calculate the components stuff. So we have a nominal diameter by 70. So the number is important. Don't forget it. So we are going to go to the another share. So we have our components in our example, if you can say our diagram or pneumatic air distribution system. It's conformed by normal airballs, tables, and shut-off valves. So we have 5 tables, 7 normal airballs, and 4 stop tables. It is the same stop tables and shop tables. It's the same. So don't get anxious. Well, we have this information that is important because it is another component. This has another measure, so it is important to know. Well, we have the second one, the second nomogram. So in this now we will do the calculation using the following nomogram. So did you remember the number that we have in the first nomogram? That is the nominal diameter. This is important, and we're going to use that number. Sorry, we're going to use that number that is 70. So if you can say in the scale, we have a line, a red line that is a diameter nominal, it says, and we're going to put in the scale 70. We find out, if you find out you're going to draw a line to the up, then we are going to identify our components. If you can see, we have a yellow line, a red line, a blue line. It's the same for it's to make sure and to identify every component that we have. Okay, so we have our line, and we're going to find out the component. For example, we have number 3. There is a number 4. Sorry, actually, sorry, I couldn't see that. But if you see, we have the number. We have a little pictures that it's number 1, number 2, number 3, number 4, number 5, and then the left we have our definition. So this is important to we have a T tables, and the yellow line is a little bit more up to the normal, so it could be in the yeah, let me get table. Yeah, it's okay. Yeah, okay. So we put all this information in this nomogram, if you can say. So you should to identify your components and start to try to nominal diameter. And if you draw this line, everything is okay. Yeah. Okay. Let's get to another results. We have this quantify will be added to the initial length. Why do we added this quantify the first initial length? So as I say, the components have measure if we doesn't uh, added this measure, we probably get a failure for our pressure. We have a bad air, a bad pressure, a lot of loss of pressure, pressure drop, and those consequences. So there's a graphic, there's a table that is all the information that we got at the second nomogram. So we have extra superatory companies quantify, extra superatory total. We have our companies is short of Babels, able Babels, the paces, or the the ones. Well, we have this measure 32 meters, 1.1 meters, and 12 meters, and all the quantified components we have, because we are going to plus this make it these components. So making the calculus, we have 195.7 meters. So this result we're going to plus the first one, that is 100 meters. So we have a result like is 295.7 meters. Well, we're going to to follow the rules, and then we have another result, another equaling. So based on the following nomogram, we are to obtain the new value of the nominal diameter. If you can say in the first one we have 70, that is because we have a length of 100, but it changed for the confidence. Now our length is 200 like 100, hurry, 195.7. So we are going to focus in the line. We're going to put the line, then we're going to put the same thing that we did in the first nomogram. It only changed for the length, and everything is okay. Well, once we have this measure, we're going to know, or take a look sorry, of diameter, nominal diameter, that is important for to get the diameter of the cylinder. So this is everything for the nomograms. The next share is for how to calculate the diameter of the cylinder, and everything is okay. Okay, let's go. Finally, we got to obtain the diameter of the cylinder using the following formula. Why the cylinder? Because there is more cheap for all the industry, and it's more easy to work it. We have this form, and where D is diameter, and centimeters, B is surface pressure, and F is force to move. F is force to move, that is in kilograms. Did you remember the diameter? Yeah. Do you remember the 70? So we have to use this, where half a force to 70 kilograms, and a pressure we have 6 bars. And now we using this data, we are going to do the calculate. So this is the result. The final result is 5.008 diameter cylinder, and that's all. I hope you enjoyed this video. So I hope you can learn something new in this case. So that's it.